So good evening, everyone. I think today many students experiencing a power cut, and I am also experiencing the same power cut, and I am connected with alternative method, and because routers and all not working when there's a power cut, you all can see the screen, right? So last week we discussed until this first page. I just started the chemistry, atomic structure of matter, chapter 3, unit 3 chemistry, and about the subatomic particles. Right, now the subatomic particles and discovered by and relative mass relative to 3 subatomic particles in an atom. Then we discuss about the Rutherford's atomic model, in other words planetary model. Right, you all can see the screen again, right? Okay, so it's subatomic particles and the position of them and the charge, relative charge, and then we discuss about this table, right? So the position of electron in an atom, that means actually electrons are evolving around the nucleus, not at the same level. There are different energy levels. We call them shells or the energy levels. You all can see the screen, this diagram. When moving away from the nucleus, the gap between the energy levels gradually decreases. So any atom, so this is the, if you can label this diagram, everyone, in your theory tube, so this is called the nucleus. And you can label first, second and third energy level. First energy level, second energy level, third energy level, and fourth energy level. So you can label the energy level first, second, third, and fourth. So we name those energy levels as designated from different the shells. So we call it first energy level known as shell K, and second energy level we call it shell L, and then it shell M, fourth energy level N. So each level there's a maximum number of electrons that can be held. So the first energy level can keep maximum 18 electrons. First energy level any atom can keep, if you can label this, first energy level of any atom can keep maximum 18 electrons. So 2 electrons, not 18, sir, 2 electrons. First energy level can keep maximum 2 electrons. Then second energy level can keep maximum 8 electrons. And third energy level can accommodate maximum 18 electrons. Around the nucleus, the fourth energy level can accommodate maximum 32 electrons distributed around the nucleus of an atom. So around the nucleus of an atom, there are or the shells, and those energies in each energy level. Any atom, whether it is hydrogen atom or any atom, if you take lithium, beryllium, any atom, the first energy level cannot accommodate. Like even around the nucleus, planets they have different orbits. So like that, in around the nucleus in an atom, there are different levels or the shells where the electrons are revolving. So any atom, around the nucleus, the first lowest energy, and this energy level has the lowest energy, and it can accommodate maximum 2 electrons. So you can complete the table also. Maximum number of electrons that can be held. Right here, the first energy level can keep maximum 2, can keep maximum up to 18 electrons. Sorry, 8 electrons. 2, 8, 18. So you don't need to write the symbol, just write 8, because I have given here the electrons, and then no need to write against it. Here maximum number of electrons highlight, because this is important when you are writing the electronic configuration that can be held in first energy level of the shell K. So those energy levels are also designated as KLMN. Right, sorry about now. I'll quickly write again. You can see the screen, right? 2, 8, 18, and 32. The maximum number of electrons that can be held in each energy level. 2, 8, 18, 32. That means first energy level can keep maximum electrons. Second energy level of shell L can keep 8 and 32 electrons. So this is called the nucleus. And one more thing, can you all observe, second and third, between second and third, gap is less, and between the last two energy levels, gap is even less than that. That means the gap between the energy levels gradually decreases. Therefore, when moving away from the nucleus, please highlight this. Away from the nucleus, gap between the consecutive energy levels gradually decreases. Gap between consecutive energy levels gradually decreases. When moving, please highlight. Energy of the energy level, please write here, energy of the energy levels increases but decreases. Energy of the energy levels increases means the gap between energy levels decreases. Please complete the blank. Decreases. Energy increases, gap between the energy levels gradually decreases. Right. Now one more, you can write here, even if you want, you can, this diagram you can write, this is the nucleus. Right. So you can write digital finish. So then one more thing you can write in your diagram, right? The last innermost of the shell K, put in and write lowest energy. Lowest energy, first one, and the first energy level has the lowest energy, and the last energy level has, so example here, fourth energy level, that has the highest energy in this one. Highest energy. Please label the energy level with highest energy and the lowest energy. Lowest energy, first energy level, highest energy, last energy level. One more thing you have to write here, before fill into the higher level. Please put a standard everyone at the bottom of this, below this page. Please put a stand right. Electrons first occupy lowest possible energy level. Lowest possible energy level. Look at the screen, everyone. You all can see the screen, right? Please raise the hand, those who can see the screen. Please raise the hand, those who can see the screen. Okay, right, can. Okay, right, okay. Now, dear children, you have to bear up with me because I am doing this today, the class with the power cut situation. Therefore, most of the technical devices are not working due to the power failure. So I'll try to resolve this by next week. Given there's a power cut, how to handle this online session so without any interruption. But today only you have to bear up with me. And anyway, I don't want to change the class or to postpone or the cancel the class because of the power failure. Anyway, you also should join with that. Anyway, if you have a problem, you can request the recording after the class. And because anyway, this is not only for I think until about April, end of May, sometimes we will have to study, or we have to continue our right. Person for electrons, so please highlight this, everyone. Electron possible energy level, lowest possible energy level before fill into the higher level. Electrons first occupy energy levels with lowest energy, or else you can write first occupy energy levels with lowest energy. Electrons first occupy lowest energy levels with lowest energy before fill into the higher levels. The shells with lowest energy before fill into the higher levels. Before fill into the higher level. That also you have to remember. Before electrons enter to the higher energy level, upper energy level, the first few energy levels should occupy. Otherwise, the first two electrons suddenly cannot, any atom, without filling the first energy level, they cannot enter to the higher level. That is very, very important. They have to follow this order. If an atom has only one electron, that should come to the first energy level. Remember that. They cannot go to the higher level, the fourth level straight away. That also, imagine up to 2 electrons, the first level can accommodate maximum of 2 electrons. Electrons cannot occupy the higher energy levels. So that you have to keep in your head. After filling the first energy level with 2 electrons, then imagine only 1 electron, that will go to the next one. If there are second energy level can accommodate maximum up to 8 electrons. So it can keep less than that also, because if an atom has just 3 electrons, then 2 electrons in the first level, 1 electron in the next level, like that. That's how it goes. So imagine an atom has only 5 electrons. Say example, if you take hydrogen, helium, lithium, beryllium, boron. So atomic number of hydrogen, helium, lithium, beryllium, boron can accommodate maximum 5 electron, right? Boron has 5 electrons. Boron atom has 5 electrons. Hydrogen atom has only 1 electron. Helium atom has 2 electron. Lithium atom has 3 electron. Beryllium atom has 4 electron. Therefore, how to put these 5 electrons to the energy levels? First 2 electrons, then the next level 3 electrons, like that, 2, 3. So that is called configuration 2, 3. This is how electrons occupy the energy levels. Now let's move on to the next page. Did you all complete this table? First level maximum 2 electron, second level maximum 8 electrons, third level 18, fourth level 32 electrons. So this is how the energy levels occupy electrons, right? That order you have to remember. And the gap gradually decreases. What are the things to remember about this? Gap between the energy levels gradually decreases. Energy of the energy levels gradually increases. Vishnu, you have a doubt? Any doubt? Anything? You raise the hand. Right. Okay. Right. Now, not in the note. This should be in your head. Right? If you forget later, you can study. Right. Okay. Now let's move on to the next page. So that's what you have to remember here. How electrons get infilled into the energy levels around the nucleus of an atom. How electrons get infilled to the energy levels around the nucleus of an atom. That is what we discuss here. Right. So all the electrons will not occupy the same energy level. There are different levels around the atom. It's like, it's like quantized. Energy is quantized. So there are different quantum levels. Now let's move on to the next page. Next page talk about atomic number. Look at the screen, everyone. This table, I will share this periodic table with you all. Now this also I'll okay, one more second, I will share this periodic table with you all. Okay, look at this. So these are the first 20 elements of the periodic table, right? So this is called atomic number. You can see this is like a unique number. Can you all see the screen? Unique characteristic. Atomic number will be unique. If you only can take a screenshot even, atomic number will be a unique characteristic. Unique characteristic. It is like identity or identity of the element. Identity of element. Example, no other element in the periodic table has atomic number 1 other than hydrogen. Atomic number 1 only for hydrogen. Atomic number means nothing else. Number of proton. I told you, if you take this hydrogen atom, look at the screen, everyone. If you take hydrogen atom, it has nucleus at the center. Look at the screen, everyone. It has the nucleus at the center. So this nucleus. The nucleus of hydrogen atom contain how many protons? Only 1 proton. Nucleus has only 1 proton, and okay, I'll write here, nucleus of the hydrogen atom has only 1 proton. Therefore atomic number is 1. Look at the screen, everyone. What is the atomic number of hydrogen? 1, because it has only 1 proton, 1 electron, 1 electron. This is the hydrogen atom. Hydrogen atom has just 1 proton, 1 electron. Atomic number 1 means this is called atomic number. Atomic number means number of protons inside the nucleus. Okay, let's see helium atom. Look at the screen, everyone. Helium atom, it has 2 protons. That's why atomic number is 2. Two protons and 2 neutrons. What is the total now? 2 protons, P, P for protons, N for neutrons. So that is 4. So the total will be 4. That is called the mass number. So atomic number means now helium atom has 2 protons. Therefore atomic number is 2. What is atomic number now? You can understand atomic number means we write this at this corner of any atom, the atomic number we write leftmost side bottom. We have to write the atomic number. It is like your NIC. Right? I don't know, maybe you might have not got the NIC number yet, but when before you apply O level or A level exam, that is your identity, national identity card number. If someone is driving vehicles, so the driving license, like that. For the atom also there's an identity, so that is atomic number. What is atomic number? Number of protons inside the nucleus. If you take lithium, how many protons? 3 protons at the nucleus. So always remember the protons are inside the nucleus. Protons are inside the nucleus. That is called atomic number. So if you take here, what is the oxygen that you inhale? What is the atomic number? 8. Means what? Oxygen has 8 protons inside the nucleus. Oxygen has 8 protons, 17 protons. That's why we call it atomic number 17. Chlorine atom, the nucleus, right? Therefore, what is the atomic number? The number of protons inside the nucleus of an atom. An atomic number is unique feature of a given element. Periodic table has atomic number 8 other than oxygen. No other element has atomic number 8, only oxygen. Atomic number 8 only for oxygen. That means 8 protons. No other right. Now let's complete this table. The theory note in your theory tube. Atomic number, right? Total number of protons. Look at the screen, everyone. Total. Can you all see the screen? Can one of you raise the hand if you can see the screen? Right, can. Okay, right. Thank you. Right. So right here, number of protons. Protons for P. What is the symbol for the atomic number? Capital Z. Z is the atomic number. What is symbol? This is the symbol of the atomic number. What is the atomic number? Number of protons inside the nucleus. Inside the nucleus, where do we get protons? Inside the nucleus. Where do we find neutrons? Inside the nucleus we find the protons. Protons and neutrons both. So there's one more relationship. Atomic number is equal to number of protons. And protons are positive, electrons are negative. Therefore, an atom is electrically neutral. Since atom has equal number of protons, an atom is electrically neutral. Can you all put a stand right here? An atom is electrically neutral. An atom is electrically neutral. An atom is electrically neutral because an atom is electrically neutral because it has equal number of protons and neutrons. Equal number of protons and neutrons. I'll highlight this pink. Equal number of protons and neutrons. Protons and neutrons are equal, therefore it's neutral. Why neutral? Because equal number of, sorry, not protons and neutrons, protons and electrons, sorry about that. Protons and electrons. Equal number of protons and electrons in an atom. Is that clear? Right. Then next one. Okay, one more thing. If you write this in using symbols, atomic number, what is the symbol? Is protons P, electrons E. That means I'll give one example. Look at the screen, everyone. I'll give one example here. Hydrogen atom. Hydrogen atom, atomic number 1. That means what? It has one proton and one electron. Hydrogen atom. Therefore, it is electrically neutral. Therefore, it is electrically neutral. If you take, I'll take one more example. If you take oxygen that you inhale, that is the 8th element of the periodic table. That means atomic number is 8. Where do we write? In case of neutral atom? In case of neutral atom, it is valid. But if atom is positive, separately in your writing book also, because sometimes it will be important when you are studying later, so you can copy down anything. Okay. Right. The next one, mass number. So if I further explain this, if you can take a screenshot of this periodic table even, I'll take one example here, sodium. Sodium, how many protons? 11 protons. How many electrons? 11 electrons, like that. So it's equal. So this atomic number is 11. If you take lithium, how many at number 3 means what? Atomic number 3. Atomic number 3 means what? It has 3 protons, 3 electrons. Number of protons equal to the number of electrons. Number of protons equal number of electrons. Right. Then let's move to the next number. Okay, what are the two important features here? One is proton and the other one is electron. Next one, mass number. Look at here, everyone. Mass number means actually sum of the number of protons and neutrons. Atomic number is only proton because they are found inside the nucleus of an atom, protons and neutrons. Atomic mass number means what? Sum of the number of protons and neutrons inside the nucleus of an atom. Sum of the number of protons and neutrons. Atomic number means only protons. So if you subtract protons from the total, then what? You will get, what is left? Neutron. Both these called mass number. Only proton called atomic number. So if you subtract mass number minus atomic number means what? Neutron. If you want to find the neutron, you can take mass number minus atomic number. How to find the neutrons in an atom? Mass number minus atomic number will give you the number of neutrons. So that means, look at the screen, everyone. Mass number means protons plus neutrons. Atomic number means only protons. Then what is, if you subtract this, what you get? Only neutrons will be left. Mass number means both. Atomic number means only proton. Then if you subtract this, what is left? Only neutron. Therefore, if you take hydrogen number of neutrons equal what? 1 minus 1, then it will be 0. Look at the screen, everyone. Hydrogen atom, no, this is the only atom in the periodic table, in this table, without any neutrons inside the nucleus. 0 neutrons, because 1 minus 1. Look at the screen, everyone. If you want, you can copy down these things, separate in your writing book. Neutrons in the hydrogen atom equal 1 minus 1, mass number 1, atomic number 1, 1 minus 1, 0. Therefore, hydrogen atom, if I draw this diagrammatically, if I draw the hydrogen atom, nucleus has only 1 proton, no neutrons, and energy level, first energy level has only 1 electron. So 0 neutron, 1 proton and 0 neutron and 1 electron. So if you want to write that is hydrogen atom, 1 proton because atomic number 1 electron because it's neutral. Protons and electrons are equal, and 0 neutrons. So this is about the hydrogen atom. Look at the screen, everyone. So this is how the hydrogen atom looks. Hydrogen atom inside the nucleus. Any atom, the nucleus has only protons, and any atom, the nucleus contains only protons and neutrons. So if you want, you can put a stand right in your writing book. The only atom without neutrons inside the nucleus is hydrogen atom. Hydrogen atom. Is that clear, everyone? Right. Please raise the hand those who are still writing about this. Please raise the hand those who are still writing about this. If you're not, wrote the entire table, because I'll give this separately, don't worry. And I have shared with you the IUPAC periodic table also. I'll share this also with you all. International Union of Pure and Applied Chemists, this periodic table. This table I have shared with your group, right? Paper class, the WhatsApp group. Okay. Right. Then you'll copy down this for your hand. Now, if a question, magnesium, who can tell me the number of protons and number of electrons? Mg, magnesium atom, atomic number is 12. That is the 12th element of the periodic table until the others copy down. Any volunteers who can tell me the protons, electrons and neutrons in the magnesium atom using that knowledge? Okay, Dimoksha.
Protons 12, neutrons 12, mass number 24.
Yeah. Protons 12, electrons 12, mass number 24. Therefore, how to find neutrons? Mass number minus atomic number. You get neutrons 12. Very good. Yeah, very good, Dimoksha. And I'll ask one more question. Okay, please raise the hand those who can give me. I'll ask next. Aluminium. So that is one of the aluminium atom. Look at, I'll highlight here aluminium atom. I'll highlight this blue. Aluminium atom. Any volunteers? I want you to tell me the atomic number, number of protons, number of electrons, and the neutrons. So this is what I'm asking. Atomic number, tell me. Protons I want you to find. Electrons I want to find. And neutrons, tell me. Any volunteers? Atomic number, protons, electrons, and all four you have to tell me now. Yeah, Kishon.
Atomic
So,
number
Atomic number 13,
electrons
protons
13,
13, electrons 13, neutrons 14.
very good, Sohana. And I think Kishon, your network connection and so neutrons 14. Both of you are correct. Very good. If you remember atomic number, you can tell two more informations directly about that atom. You can tell what? Proton number you can tell, electrons you can tell. Any atom. Okay, example neon. This is neon. Protons 10, electrons 10. Because atomic number 10. If you take, say, oxygen, atomic number 8 means protons 8, electrons 8. And how to find neutrons? Upper one, mass number minus lower one, atomic number. That's how you find the neutron number. They will not, the mass number is given in the exam. Out of these two, okay, I'll erase this again. Remember, children, this is given in the exam. Mass number is given in the exam. No need to worry about that. This upper value, the superscript, mass number is given in the exam. Given in the exam. They will never ask the mass number of an element. Even in A-level paper, they don't ask. Even in A-level chemistry paper, they don't ask the mass number. Given in the exam. But atomic number should remember. You have to remember the atomic number. That means what? First 20 elements you have to remember. Is that clear, everyone? Atomic number you have to remember, should remember. That means atomic number means what? Hydrogen, boron, carbon, nitrogen, oxygen, fluorine, neon, 11th one sodium, 12th magnesium, 13th aluminium, 14th silicon, 15th phosphorus, 16th sulfur, 17th chlorine, 18th argon, now 19th potassium, 20th calcium. These 20 you have to remember in the increasing order of the atomic number. Without study chemistry, or if you are going to answer any questions from chemistry, you will find the chemistry very difficult. Why? Atom more than nearly 118 elements now discovered, but only the first 20 elements. Even in the here only less than single and the English alphabet. 20, not to write from top to bottom. You should be able to construct this table. I'll teach atomic number. So atomic number is unique for a right. Now I'll share the screen again. Right, I'll share the screen again. Okay. Now let's complete second one, mass number. I think if you have, please raise the hand. Those who have got the printout of this tube. How many of you have got the printout of the hard copy of this? Right. Good. Right. Okay. Very good. Those who have got the printout, very good. Okay. So the next one, right? Mass number. Mass number is equal to what? Capital A, the symbol. Symbol of the mass number is capital A. Sum of the number of protons and neutrons. Sum of the number of protons and neutrons. Sum of the number of protons and neutrons known as protons right, equal to the number of protons and number of neutrons. Okay, so did you all get it? Mass number is equal to the sum of the number of protons and neutrons. Write the using symbols of this. Give me a second. Some students are again in the waiting room. Right. Okay, so I told about this mass number is equal to the sum of the number of protons and neutrons inside the nucleus. Therefore, the mass number is what? Mass number equal sum of the number of protons and neutrons. So please label in this diagram symbol 1. This is known as, this capital A is known as what? Mass number. And capital Z is known as atomic number. Atomic number. And X will be the symbol of the element. So this is the standard notation, standard way of, or it is standard notation of, standard notation of writing symbol of an element, of writing symbol of the element with atomic number of, with atomic number and the mass number. This is the standard notation of writing the atomic number and the mass number of an element. This is a standard notation of writing the atomic number and the mass number of element. X will be, X is not the real symbol, right? So X can be the symbol of any element. This is the symbol of the element. This is the symbol of the element. Symbol of element X. And A will be the mass number. I'll highlight here. A mass number, Z atomic number, and X will be the symbol of the element. Now, please write everyone. This side, I have given the example sodium. Look at the screen, everyone. Sodium, what is 23? Mass number. That means what? 11 means atomic number. That means sodium atom has 11 protons. Look at the screen, everyone. This has 11 protons. Sodium atom has 11 protons. And I'll highlight this red. Sodium atom has 11 protons inside the nucleus. Then what is this 23? Sum of the number of protons and neutrons. Total protons and neutrons given by 23, that is the mass number. So actually here 11, now 23 consists of the same amount of protons, 11, because protons are inside the nucleus. Proton plus 11 plus what is 23? 11 plus 12 neutrons. 11 plus 12 neutrons, that will be the sum of the number of protons and neutrons. Is that clear, everyone? So please try that. I'll give one more example. You can write, okay, I'll write this one. I'll give one more example. Let's see aluminium atom. Look at the screen, everyone. I'll give one more example for your understanding. One more example for this. I'll write aluminium atom, Al. Aluminium atom, what is the aluminium atom, the atomic number? So which aluminium is which element? I mean, what is the order? So the 13th element, aluminium is the 13th element of the periodic table, 13th one. And this one you have to remember, they don't tell the atomic number of aluminium in the exam, that you have to remember. That means 13, atomic number 13 means aluminium atom has how many protons inside the nucleus? There are 13 protons inside the nucleus of the aluminium atom. So I'll write here 13 protons inside the nucleus. 13 protons. Now in the exam, they will give the mass number. What is the mass number here? 27. That is given in the exam. Don't worry. So atomic number, if you want to write, is given in the exam. Sorry, should remember this 27. They will never ask. That is given in the exam. Given in the exam. It is given in the exam. No need to worry about the mass number. Any atom, the mass number, they will never ask. But atomic number should remember. This atomic number should know. You should know the atomic number. Right? You should know the atomic number. And then if you are given the mass number, you can find how many neutrons. How? Subtract 13 from 27. If you subtract 13 from 27, you can easily get the number of neutrons. How to get the neutrons? Subtract 13 from the total. Total 27. 27 will be the both protons and neutrons. So what is the answer here? 13 protons plus how many neutrons? 13 plus what is 27? 13 protons plus what is 27? 14 neutrons. If you only can make a small scale this diagram even, then it's easy to understand in the exam. I'll draw a small diagram and show you this. So if they give protons in the aluminium atom nucleus 13 protons, then you can easily find the neutrons. Why? The total 27. Here the total you get 27. How to find the rest here? That is, I think that this is easy to understand. If anyone of you finds it difficult, then its best method is what? You can draw the structure of the aluminium atom, and you can mark inside the nucleus how many. The total anyway 27. Total will be 27. Total will be 27 here. So I'll write here total 27. That is given in the exam. That is given in the exam. Total here nucleus, the total 27. That is called the mass number. So atomic number 13 means what? It has 13 protons. 13 protons. Then how to find the neutrons? 27 minus 13. That means there are 14 neutrons. How did you get 14? How did you get 14? 27 minus 13. Right? How did you get 14? 27 minus 13. 27 minus 13 is equal to 14 neutrons. Therefore, any atom, if you subtract the atomic number from the atomic number, if you subtract from the mass number, that blue one you subtract from the green one. 13 you subtract from 27, you get the number of neutrons. So that's how you find the neutrons. So again I am telling which one you have to remember. Atomic number. First 20 elements you have to remember. Mass number, do you need to remember? No, it's given in the exam. If they give the mass number, you can get the number of neutrons. So again I am telling protons and neutrons are found inside the nucleus under any instance, or even during chemical reaction or any other instance. Protons and neutrons remain always inside the nucleus and they are not going to change. Right? Now who can tell me the number of electrons in this atom? How many electrons should be there here? Any volunteers? Who can tell me how many electrons should be there in the aluminium atom to make it neutral? Out of these three, which one is positively charged? Protons are positively charged. Electrons are what charged? Negative. Neutrons are neutral. And electrons are negative. So to make it neutral, to make the aluminium atom neutral, neutron number will not, there's no effect from the neutron number. So the charge depends on protons and electrons. Last week also I told about this. Okay, I'll ask the answer from Sohana, Dimoksha.
13.
Very good. Yeah, it has 13 electrons. Very good, excellent. So it has, if you only can mark that also, right? If you only can mark that also. It has 13 electrons. Right, everyone? It has 13 electrons. Then only it's become neutral. 13 electrons. 13 electrons. Right. How many electrons? 13 electrons are there. Are all these 13 electrons at the same level? No, they are at different levels. That also you should know. We'll come to that later. So did you all get it down? What are the two numbers here? Atomic number and mass number. Right? Atomic number, should remember, atomic number is the protons, number of protons. Mass number is protons plus neutrons. So it's given in the exam. It's given. This one you should know. Right? That also you can mark with a pencil. Right? Mass number they will never ask. They will never ever ask, even in A-level chemistry, the mass number of any element, right? No need to worry about that. Mass number is given in the exam. Atomic number you should know, right? When you are given that, if you know the atomic number, you can tell two things directly. What? If you know the atomic number, you can tell protons and electrons in any atom. If you know the atomic number in any atom, you can tell the protons and the electrons, right? Right, now we are moving to the next part. The next subtopic, electronic configuration. I'll erase the screen now. I'll erase the screen. Right. Now electronic configuration means the order of representing, the representation of the order of filling electrons to the shells. What is electronic configuration? I told you all the electrons do not occupy the same level. So this is the order of filling electrons to the shells. That means what? Who should get filled first? The lowest energy level. The lower energy level is the lowest energy should get filled first. Example, the first energy level should get filled first. So with 2 electrons. Then the rest goes to the next level. 8 electrons up to maximum, like that. So any atom, the first level can keep, the first energy level can keep maximum up to 2 electrons, and the rest goes to the next level. And after that, so this order, we are not drawing the circles and write for the configuration. This is example, we write here 2 comma 8 like that, 2 comma 8. Okay, now just now the power came. I think the battery is about to drain. Okay, now I think you won't get interrupted again. 7 o'clock. Okay, it's right now. I'll connect through the now let's see what is electronic configuration. Right, okay, okay, let's move on. Electronic configuration is, I'll use a white screen, white background to try explain this. Done. Okay, look at the screen now. Okay, can see the screen, right? Okay, now if you take order of fill-in electrons, so this is the order, so underline here order of fill-in electrons to the shell, so the energy levels. So example, if you take hydrogen atom, it has 1 electron, atomic number 1 electron, so it has 1 electron. So how to write this 1 electron? The configuration is 1. If you take helium, there are 2 electrons, atomic number is 2, means there are 2 electrons, so then the configuration is what? 2. If you take lithium, atomic number is 3, that means lithium atom has 3 electrons. How this get filled? Now if you take look at the screen everyone, hydrogen atom, it has just 1 electron, so it will be here. Helium atom has 2 electrons. Helium atom has 2 electrons, so it will be 2 electrons here. Lithium atom, if you want, you can draw this if you want. Lithium atom has 3 electrons, and when you draw this, you can't put all 3 electrons to the same level. Lithium atom is bit larger than hydrogen and helium. Lithium atom is bit larger than hydrogen and helium. Then what happened? First 2 electrons come to here, and the rest goes to the next level. That is, we call it what? 2 comma 1. How to write the configuration? 3 electrons means you are right here 2 comma 1. How come 2 comma 1? Can you put all 3 into the same level? Can't. Any atom, I told you, first level can accommodate maximum 2 electron, and the next level can accommodate up to 8, and the rest goes to the next level like that. 2, 8, 8, there's an order we have to write. 2 comma 8 comma 8 like that. So this is the order. There are 4 electrons. Then how come how electrons get filled into this beryllium atom? beryllium atom, first level can accommodate maximum 2 electrons. Any atom, the first level 2 electron, the rest goes to the next one. How many more remaining? 2 electrons. Then we call it 2 comma 2, like that. So it can go up to 8. The second level it can go up to 8. So this, I'll highlight this order or this method of writing, representing the order of filling electrons to the energy levels, known as electronic configuration. Electronic configuration. Look at the screen, everyone. What is this called? Electronic configuration. This order of filling electrons, if we represent using this method, we call it order of filling electrons to the nucleus of an atom, around the nucleus of an atom. I have given a separate table next page top. Let's complete the electronic configuration of those. I'll after that come to the page number 2 bottom. Right? Look at the screen, everyone. Next page top. Here I have given page number 3 top. Look at the screen, everyone. Page number 3 top. Right. Don't worry about this. Don't complete everything at once. So we'll write only up to the configuration. Right? Only up to the configuration. Beryllium atomic number is 4. Let's complete this. Beryllium atomic number 4. How many protons? 4. How many electrons? 4. Configuration 2 comma 2. Only up to here. Boron, the fifth element, atomic number is 5. There are 5 protons. There are 5 electrons, and configuration 2 comma 3. This 2 comma 3 can go up to how many? Up to 8. This is the outermost shell here. Outermost, this one can keep maximum 8. If you can mark with a pencil, can accommodate maximum up to how many electron? Can accommodate maximum up to 8. Can accommodate maximum up to 8. Can accommodate maximum up to 8. Can accommodate or can keep maximum up to 8 electrons. Can keep maximum up to 8. Right? Without completing that, electrons will not jump to the third level. So how many levels electrons are in, how many energy levels in this beryllium atom? In electrons are in 2 different levels. Boron atom, electrons are in how many different levels? Electrons are in 2 different levels. First level 2 electrons, next level 3 electrons. Next one. Let's write the configuration of carbon now. Look at the screen, everyone. Carbon atom. Atomic number 6. Proton 6. Electron 6. Configuration 2 comma 4. 2 comma 4. What is it called? 2 comma 4 means configuration. Electronic configuration. What is electronic configuration? This is how electrons get filled to the energy levels of the shells around the nucleus of this carbon atom. Okay, let's move on now. I'll erase this. Now nitrogen onwards. Look at nitrogen. Nitrogen is what? 7th element of the periodic table. Nitrogen is 7th element. Atomic number is 7. So atomic number 7, proton 7, electron 7. What is the configuration? 2 comma 5. 2 comma 5 means first level 2 electron, next level 5 electron. 2 plus 5, 7. There are 7 electrons. So here atomic number, here protons, here electrons, here the configuration. Is the configuration. So it's there, the heading is there at the top, right? I just to remember, I highlight this. Atomic number is at protons P, electrons C, and this is the configuration. Now let's continue. You can do it alone without my help. Now you can continue. Oxygen atomic number 8. Protons 8. Electrons 8. Configuration 2 comma 6. Configuration 2 comma 6. Then fluorine atomic number 9. Protons 9. Electrons 9. Configuration 2 comma 7. Electronic configuration 2 comma 7. Neon atomic number 10. Protons 10. Electrons also 10. Configuration 2 comma 8. Now I'll highlight this one. Why? This is called, now it's filled. You can put a you can write this if you want separate. This is filled. This is what? Filled now. This is filled with this cannot keep more than 8 now. When you try the next one, now one extra electron. When it's come to the sodium, look at the screen everyone. When it's come to the sodium atomic number 11. So it has 11 protons and 11 electrons. 11 electrons. Now you can't make it 2,9. Why? Now it is filled. Cannot keep more than 8 in the next level, second level. Second energy level. I highlighted this blue. You also can mark with the pencil and write. Cannot keep more than 8 in the second energy level of any atom. Second energy level or the second shell of any atom cannot keep more than 8 electrons. If there are more than 8 electrons, the rest goes to the next energy level, that is the third energy level. So that's what we have to start the third energy level from sodium. Why? Second level cannot keep more than 8. 2 plus 8, 10, then there's one extra electron that goes to the next level. So this third level begins to fill from sodium. Until sodium, the last electrons getting filled to the second shell or the second level of the atom. Right? Until sodium, second shell can keep maximum 8, then the next electron get filled to the third level. So what is this called? Electronic 2,8,1 is called what? Electronic configuration of sodium. So in the exam they can ask all this. Right? They should not give even, without atomic number, you should know 11th element is sodium. Therefore sodium has 11 protons, sodium has 11 electron. Configuration 281. If you can't do that one, that everyone should study that and remember. They will not tell the configuration of sodium. You should know how to write it. Okay, magnesium, 12th element. 12th element means atomic number 12. So this corner is 12, right? This corner is 12. Now atomic number 12 means it has 12 protons and 12 electrons, configuration 282. 282. Aluminium, atomic number is 30. Aluminium atomic number is 30. So protons 30, electrons 30, configuration 2,8,3. Silicon atomic number 14, protons 14, electrons also 14, configuration 284. Are you all writing? Okay, next one, who can tell me phosphorus? Okay, shall I read the screen? Please raise the hand those who are still writing. Okay, when you're done, please lower your hand. Okay, right. Now let's move to the next one. Phosphorus. Who can tell me the electronic configuration of phosphorus? Any volunteers raise the hand? Who can tell me the electronic configuration of phosphorus? Any volunteers? Phosphorus. We will start with phosphorus now. I'll ask the answer from Sandusha.
285.
Very good. 285. Okay, I'll write it. Atomic number 15, protons 15, electrons 15, 285. Very good, Sandusha. 285. Then sulfur. Who can tell me the electronic configuration? There are 16 electrons. Dimoksha, Sesat.
286.
286.
Very good. Atomic number 17. 17th element is chlorine. Proton 17, electron 17. Who can tell me the configuration? Sohana.
287.
Very good. 287. Argon. Who can tell me the electronic configuration of argon? Atomic number 18, protons 18, electrons 18. Others, the same set of students raising the hand most of the time. Sandosha, Dimoksha.
288. 2881.
Argon 288. Argon 288. Right. The next one, potassium. Atomic number 90. Now, this one highlight, this is one turning point. Now, it cannot accommodate more than 8. Now, the third level, actually I told earlier 18, but 18, there are sub levels. So, first level 18 and the next goes to the rest. So, it's up to 10. So, the third level can accommodate 18, but it's divided into two sub shells. The first sub or the sub level or the sub energy level can accommodate 8, and then the rest goes to the next one. Therefore, we have to follow this 288. So, this you cannot fill more than that into the third level. Right? Okay. Then atomic number 19, potassium, I'll write to the different color. 19 protons, 19 electrons, it become 2881. So, this is 18, 288, 18 plus 1, 19. Understood? Then next one, calcium. Calcium, atomic number 20. Protons 20. Electrons 20. Configuration 2882. 2882. The last two you write with a different color because it's there's one the patterns changes now after that. Now 288. So this is a bit important, these two, right? Okay, potassium, calcium, the configuration fourth level begins to fill. Now based on this, you can construct the periodic table also. You can construct the periodic table also. Don't worry about these other columns. Will be fill in one by one because I have given everything in one table. This is easy. Otherwise, you're in the textbook they have given the same table repeated several pages. To avoid repetition of the same table again and again, I have given everything in one page, so that is easy to study also when the exam is close. Anyone still copy down? Shall I read this now? So what is the 20th element? Calcium. No, that is the last element you have to remember. You have to remember the elements only up to 20. Atomic number 20 is calcium. 20th element is calcium. You don't get, they will never ask configuration more than 20, right? They will never ask the electronic configuration more than 20. Never. Maximum up to 20. So shall I read the screen? Anyone still copy down? Done, right? Okay, I'll erase the screen now. Right. Then next one, we can construct the periodic table also based on this curve. What is the importance of electronic configuration? Don't worry about this part, I will complete, right? Ions, formation of ions, I will complete after that. Now we can construct the periodic table based on the electronic configuration. Right? Okay, look at the screen, everyone. Okay, look at the screen. Please write in your write-in book. Please, everyone, write in the write-in book. Constructing the periodic table based on the electronic configuration. Construction of the periodic table. Please write this heading, everyone, in the write-in book. Construction of periodic table, that is atomic number 1 to 20. Atomic number 1 to 20 based on atomic number and based on the atomic number and electronic configuration. Based on the atomic number and the electronic configuration. Construction of the periodic table based on the atomic number and the electronic configuration. Write that in, everyone, in the writing book. This in your writing book, CR book. Right. Now I want you to okay, if you want, you can write in the writing book also hydrogen, helium, lithium, beryllium like 20. Then we'll look at the, or else you can look at your theory table, the configuration, and we'll construct this table now. I have given the table, then it's like magic, so you should know how to construct without my help. Look at the screen, everyone. Now periodic table, how many columns are there? So there are 8 columns. There are 8 columns. Right. You can have the table with 8 columns like this. Right. Look at this. 1, 2, then 3, 4, 5, 6, 7, 8. Right. Okay, so you can write here Roman number here 1, Roman number 2, the second column, the Roman number 3, the third column. There are 8 columns, vertical columns. Roman number 4, Roman number 5, Roman number 6, Roman number 7, Roman number 8. There are 8 columns. So this one actually there's one more above this. I'll put one more page here. There are 8 here. So these are 8th one. Right. So there are 8 vertical columns in the periodic table. There are 8 vertical columns, and this side we put the rows here: first row, second row, third row, and the fourth row. Okay. Now let's see, by looking at the configuration, you can decide the position of that element in the periodic table. Example, hydrogen is 1. Look at the screen. Hydrogen, the first element, its configuration 1. Therefore, it comes to here. Hydrogen H. Right. Then helium He configuration is 2. Why? Atomic number 2 ne? Configuration, it has only 2 electrons. Helium atomic number 2, configuration also 2. So it's come to here. Sometimes you might ask, why can't we put this under group 2? Because configuration 2 ne? There's a reason by putting under. I'll give the reason. There's one exception. Helium comes under group 8 because the properties won't match with the second group elements. That's the reason. Properties won't match with the second group elements, not only the configuration. So now if you take lithium 2, 1, outermost shell 1 electron. If there's only 1 electron in the outermost shell, they all come to the group 1. All the elements with outermost shell 1 electron, they'll come to this group. Look at the screen everyone. 2, 1. I'll write one more example. Check with your table. There's one more element. Okay, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium. I'll write this side. Silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. Look at the screen everyone. Now I'll write this configuration again. Hydrogen 1, helium 2, lithium configuration is 2, 1, beryllium 2, 2, boron 2, 3, carbon 2, 4, nitrogen 2, 5, oxygen 2, 6, fluorine 2, 7, neon 2, 8, sodium 2, 8, 1, magnesium 2, 8, 2, aluminium 2, 8, 3. So because you have this, right? You have this in your that table. Anyway, even the this is silicon 284, phosphorus configuration 285, sulfur 286, chlorine 287, argon 288, then 287, then 288, 18, then 19th one is potassium 2881, calcium 2882. Okay. Now outermost, all the elements with outermost shell 1 electron, lithium, hydrogen, who else has outermost shell 1 electron? Sodium, and potassium. These elements, outermost shell 1 electron means they all come to the same group. So what is the common pattern now? This is one low, periodic low, or one trend or the pattern you have to remember. Any element with outermost shell 1 electron, they all come to the same group, that is group 1. Hydrogen, then lithium, then lithium sodium, then potassium. Why? Their outermost configuration is 1. If electronic configuration ends in 1, they all belong to the same group. They all belong to the same group. If you want, you can write the configuration also here. It's 1 here. It's 2 1. If you please copy down this, everyone. This is 2 8 1. This is 2 8 1. This is 2 8 8 1. Look at the screen, everyone. So outermost shell 1 electron means they all belong to the same group. Therefore group P equal the number of electrons in the last energy level. Please write that if you want this separately, put a standard below this. I have copied down the CR book. In the CR book, please write down this group number. So these vertical columns are called groups. These vertical columns are called what? Groups of the periodic table. These vertical columns are known as groups. These vertical columns of the periodic table are called groups. What are groups? The vertical columns. Vertical columns are called groups. How many groups are there? There are 8 groups. There are 8 groups. Now, group number is equal to the number of electrons in the last energy level. So I'll put a stand right separately. Group equal, group number is equal to what? Number of electrons. If there's 1 electron, group 1. If there are 2 electrons, group 2. Number of electrons in last energy level. Number of electrons available in the last energy level is equal to the group number. Last energy level. Is that clear? Group number is equal to what? Number of electrons in the last energy level. Example, last energy level 1 electron, group 1. Last energy level 2 electrons, group 2. Last energy level 3 electron, group 3. Okay, I'll give one more example. Look at here, second group. Okay, can you find what elements will belong to the second group? Outermost 2 electron are beryllium. Outermost shell, the last energy level 2 electron, magnesium. Last energy level again 2 electron, calcium. They all come to the same group. I highlighted them purple. Look at the screen, everyone. Group number is equal to the number of electrons in the last energy level. Now I'll write here. And the other one is how to decide to which level they belong, so which horizontal row. These horizontal rows are called, if you can highlight this and write this side, we call them periods. These horizontal rows are called periods. What are these horizontal rows are called? Periods. How many periods are there? 4 periods. How many periods are there? 4 periods here. These horizontal rows are called periods. First horizontal row, only 1 energy level. Second horizontal row, the 2. Okay, this is the other one. Look at the screen, everyone. Horizontal rows are called period. The period number is equal to what? The period to which they belong is equal number of energy levels. Number of energy levels. Or in other words, we call it number of shells. Number of shells containing electrons. Number of shells containing electrons. Please highlight, write these two conditions. So the period number to which row they belongs, how to decide? By looking at the number of shells. To which group they belongs, how to decide? By looking at the outermost shell. What are the two things you have to look at now? It's like a puzzle, across and the down and across. Down, how to check? Look at the last energy level. Across the period now, to which horizontal row they belongs, how to decide? by looking at the number of shells. So if there are 2 shells, they all belong to the second row. Second, number 2 here, number 2, second row, this row. If there are 3 energy levels, if there are 3 shells, look at here, sodium to argon, they all belong to the same row. Why? They all having 3 energy levels, 281, 282, 288. Electrons are in 3 energy levels. Up to neon, electrons are in 2 shells or 2 levels. Okay, now let's continue. Who can tell me to which group and to which period beryllium belongs? Beryllium outermost 2 ne, therefore it should belongs to which group? Who can tell me? Beryllium should belongs to which group? Which group means which column and which row? Mandusha? Beryllium should belong to which column and which row? Second group. Which row or which period? Second period. Second period. So example I write the configuration is 2, 2. 2, 2. 2, 2 means what? Outermost 2 electron, group 2. If you write, I'll write it downwards and it's easy. Then what is the next one with 3 shells? The third row, there must be 3 energy levels and outermost 2 electron. That is magnesium. Magnesium, outermost 2 electrons and there are 3 energy levels or 3 shells. Why 3 shells? Third period. Why 2 electrons, outermost 2 the second energy level. Therefore, by looking at the configuration, we can decide the position of that element in the periodic table. How to decide the position of that element in the periodic table? Based on the electronic configuration. Based on the configuration. You can decide the row to which it belongs as well as you can decide the group to which it belongs by looking at only the configuration. By looking at only the configuration. Now calcium. Calcium outermost, how many electron? 2 electron. Therefore group 2. How many, to which row it belongs? The fourth row. Why? There are 4 energy levels here. 1, 2, 3, 4. There are 4 energy levels. Electrons are in how many levels? Electrons are in how many different shells in calcium? The last element. Look at the last element. 2882. Outermost 2 means group 2. Group 2 there are different levels. All this in the group 2. Beryllium, magnesium. Therefore it will come to the fourth row or the fourth period because there are 4 energy levels. Because there are 4 energy levels. Calcium 2882. 2882, therefore outermost 2, group 2 belongs to. So I'll highlight this purple. They all having, why purple? They all having the same number of electrons in the last energy level. Same number of electrons in the last energy level. Same number of electrons in the last energy level. Group 1 outermost 1. Group 2 outermost 2. Group 2 outermost 3. Group 3 means outermost 3. Let's see which elements. Okay, who can tell me the 2 elements belong to the third row or third column, third group or the third column? Who can tell me? What are the, out of these 20 elements, what are the elements belong to the third group or the third column? Check which electrons have been outermost 3 electron. Any volunteers? Dimaksha?
Boron, aluminium.
Very good, excellent. Boron and aluminium belongs to the third group or the third column because the electron configuration ends in 3 electron. 2, 3, 2, 8, 3, outermost 3, group 3. Actually, they lose 3 electrons. They can easily lose 3 electrons and they can become 3 plus. 3 plus ions. So I'll come to that later. Let's see the formation of the ions later. First, let's build up the periodic table. I'll highlight them with a different color. I'll highlight them blue. Right, blue. What are boron ends in 3 and who else? Aluminium ends in 3 electrons. Al. It's here 283. 283. So it's 3 electron. Aluminium 2, 8, 3 because atomic number 13. 13th element. So it's 283. Outermost 3, group 3. Right. I'll highlight here aluminium. Okay. The next one. What elements belong to now? Group 4. Outermost what are the 2 elements? Electronic configuration ends in 4. They should belongs to the group 4. Group 4 also the second row, second horizontal row, what should come? If there are 2 shells, they will come to the second row. If there are 3 levels, 3 shells or 3 energy levels, that will come to the third row. So both the conditions must be satisfied. 2 energy levels and outermost 4 electron. Here 3 energy levels, outermost 4 electron. Electrons like this here. Electrons, there must be electrons in 3 different levels. Here electrons are in 2 different levels. Outermost should be 4. What is that? Any volunteers? Tell me the 2 elements belong to the group 4 now. Usman?
Carbon, sulfur.
Very good, Usman. Carbon and sulfur, very good. Carbon and sulfur both under the same group. Carbon and not sulfur. Sulfur is S, Usman. That is 286. Silicon, Si. Here Si means not sulfur, silicon. Carbon and silicon, I'll write the configuration. 2, 4, outermost 4, group 4, 2 levels, therefore period 2. Silicon 284, outermost 4, group 4, there are 3 shells, 3 levels, electrons are in 3 energy levels, so 3 shells, therefore period 3, third period. Right, I'll highlight this with a different color. I'll use green. Carbon 4, here 4. Outermost 4, therefore group 4. Are you all copying down this table nicely? Because this is not given in your textbook. With the configuration, they have not given this in the textbook. Right. So we are going to build the periodic, rather than just memorizing directly the periodic table. We are constructing the periodic table. How? By looking at the configuration. By looking at the configuration, we are building up the periodic table by ourselves. Now we have to complete the 5th column, vertical column. Vertical columns are called groups. If you want to write that, if you want separately, vertical columns are called what? Groups. Right below this table if you want. Vertical columns are called groups, and horizontal rows are known as, below this in your writing book, CR book, if you have some space, right at the bottom on next page. Horizontal rows are known as periods. Horizontal rows are known as periods. Vertical columns are called groups. Right. Vertical columns are called groups. Horizontal rows are known as periods. Done? Okay. Please copy down all this because it's a short note, like very important. You can have 1 page, everything, then no need to memorize long paragraph in the textbook or even in the theory table. Right? This is a very important concept. Now you can try this again at home without looking at this note. Okay, now let's come to the 5th column. 5th group, group 5, Roman number 5. Who can tell me the 2 elements belong to this? What are the, look at the outermost shell and tell me how, like look at the outermost electrons and tell me what are the 2 elements out of the remaining elements which come to this column, or the which comes to the group 5. Yes, any volunteers? Check the, look at the configuration, look at the outermost shell and tell me. Yes, hurry up. You know the method now. You all got the method. Yes, the same set of students raising the hand. Dimokshan, Sandhu. What about the others, other students? Can't you see the electronic configuration and the how many electrons in the last level? And can't you decide the group? Even grade 6-7 students can decide this if I teach them the technique or the method. Very simple technique. Yes, Rashmita, Malitma.
Nitrogen and phosphorus.
Nitrogen.
N nitrogen.
P.
P phosphorus. Yeah. If you don't know the name, just tell me, sir. N and P. That's all right. If you maybe you are not familiar with the name, capital N and capital P, nitrogen and phosphorus. Why can't you look at the WhatsApp group? I gave the long form of the periodic table with the name, because you can get the name there. Can you remember this table? I have WhatsApp you this. Even you can look at the textbook and tell me. Even you can look at the textbook because all the symbols, the name they have given in the textbook. This table, periodic table with IUPAC, this one you can see the name here. This long form of the table I have given you. All 118 elements you have here, long form. But here there are 18 groups. But O-level syllabus you have only 8 groups. Right? Helium in the long form 18th group, but your table helium is in the 8th group. Therefore, O-level periodic table has only 8 columns, only 8 groups, right? A-level and beyond that university level 18 groups, right? Now I'll write the answer here: nitrogen and phosphorus, because they are outermost shell N and P, 2,5, outermost 5, group 5. There are 2 shells, that's why the second column, second row, there are 3, phosphorus has 3 energy levels, or phosphorus has 3 shells, that's why it comes to the third row or the third period. I'll highlight with what is the color I use for those two. I'll use a different color. I'll use say this maroon color. Right. What is that? Nitrogen and phosphorus. Nitrogen and phosphorus. So they all come to the same group. Now who can tell me the elements belong to the 6th column or the 6th group? Look at the configuration and tell me, hurry up. Those who never tell me or open the mouth. At least now. It's easy, not hard. Any volunteers? Same set of students raising the hand. Look at, and just no need the name. Just tell me, sir, this N and P, O, F and N, like what? You tell me the English letter. Look at the outermost shell electrons. Count the number. Like you can see the configuration. It's already there. Say Sat, yes.
Oxygen, sulfur.
Yeah. Oxygen and sulfur, good. Oxygen and sulfur. Oxygen and sulfur. So I'll write here O. Why O here? Because oxygen outermost shell 2 electrons. Why can't I put oxygen here at the bottom? Why can't I how to decide? Now oxygen group 6. How to decide whether it belongs to the third row or the second row? Any volunteers? How to decide oxygen is belong to the second row or the third row? Because oxygen has only 2 shells. Look at here, oxygen has only 2 energy levels. 2 shells. That's why therefore it should come to the second row. It should come to the second row. Look at here, oxygen should come to the second row. And sulfur third row. But in the same column in different levels, depending on the number of energy levels they have. So therefore oxygen I had to put not at the bottom, at the top. Why? It has only less energy levels, that means only 2 shells, though I put here 2,6. Sulfur 286, outermost 6, group 6, outermost 6, group 6. Right. The next one, so it's 286, 2,8,6, outermost 6, group 6. Then next one, group 7. Group 7, who can tell me? Okay, very good. Dimoksha, what about the others? Tell me the 2 elements out of these, only few more elements remaining. Look at the remaining elements, the ones leftmost side. Tell me, look at the ones that I have not highlighted and tell me. Those who are able to unmute. Netuli?
Fluorine and chlorine.
Very good, Netuli. Fluorine and chlorine. F and Cl. Why fluorine at the top? Because fluorine comes to the second level or the second row or the second period. Why fluorine at the second period? Because it has 2 shells. Both sides you have to check. Down and across. So why is 7th? Because outermost cell 7. Why it's second row, second period, there are 2 cells. Chlorine 287, outermost 7, group 7. 287 means outermost 7, group 7. Right. So I'll highlight this with different color. I'll use pink. Did I use pink? No, I'll use pink here. Okay, fluorine. Actually, they are colored gases. Fluorine outermost 7. Chlorine also outermost 7. They all come under group 7. Right. The next one. How many? Only the last 3 electrons left. Even this nicely matched. One exception, helium. Helium, this is one drawback of the modern periodic table. actually according to the configuration, helium should be here because helium configuration 2 ne? Look at the screen everyone. Helium, the configuration is 2, right? It's 2 ne? But we have put this under 8. Actually the helium should come under this. Then why it is here? Helium is a gas. Beryllium, magnesium, calcium, they are all the others in the second group. They are solid and they are metal. Properties do not match. Configuration okay, but properties won't match. That's why we can't put helium under second group. All the other elements is nicely matching group equal outermost electrons, number of electrons in the last level. Group number is equal to the, look at here, I have put the under green the condition there. So you should copy on that also. I think if you can copy on all this in the same page, that's very good, no? Because configuration, I think it's in the theory. You can refer that also and complete this. This is one drawback of the modern periodic table. This is one drawback of the modern periodic table. What is the drawback? Position of helium the problem. Position of helium is the problem. Why? Helium configuration does not match with the group 8. But anyway, can't help, they have given the priority for the properties rather than the configuration in case of helium. Not only the configuration, elements in the same group, similar properties. What this hydrogen also the position problem. Your lithium, sodium, potassium, they all solid metal, but hydrogen is a gas. Some long form of the periodic table, especially if you take in the internet, sometimes hydrogen they put separate in somewhere in the middle above this table. Hydrogen and helium problem in this table. Actually, why this periodic table is constructed? To make the chemistry easier. To make the chemistry easier, because when there's a lot, you have to classify, you have to categorize, you have to, it's table because to make the chemistry easier, this is the alphabet of the chemistry. Without knowing these 20 symbols in the correct order, in the correct sequence, with the correct electronic configuration, if you are going to study chemistry, that's a joke. It's like you are going to do an English degree without knowing the alphabet. If someone is going to study chemistry without knowing this periodic table, he is trying to do something like going to do an English degree or diploma without knowing the English alphabet. It's same as that if someone is going to study chemistry without knowing the periodic table, right? Therefore, my advice, within one day you can't memorize this table, right? So if you're going to memorize this table and like keep on, like it's like you will fed up with this subject also and you will be in the mental hospital. You can't do it. But when you are frequently using this table again and again, you will automatically remember this. I will give one of the example. Here only 20 symbols. In your school, you are maybe you have not visited the school much in this year and last year, but anyway, you can remember the all 40 students. Sometimes there are 30 students in your classroom. You can remember their name, surname, some of your friends, you know the telephone number and address also. Have you ever come home and memorized those names? I should remember all 40 names of my class in grade 1. No, you never memorize. You automatically remember all 40 students' name. Whenever you see them in the school, you know the name. You never ask, I can't remember your name. Can you please tell me? Have you ever asked? No. First day only you ask. Now, how did you remember this? Easily. Because frequently you are using every day in the school, you call that person using that name and you see them. You frequently associate with them. Same scenario when you are studying chemistry also, you should be familiar with this table. How? You have to practice many questions. So when you are answering questions, you need this table. When you are frequently using this table to study chemistry, automatically you will remember. No need to memorize this separately within one day. So don't do it. I am not forcing you to study this table and tell me by heart by next week. I am not doing like that. Then I will not be a teacher. Like kind of a different thing. Then not teaching, right? So this is like very logical subject, right? So any subject to a certain extent, memorizing part is there. But without studying, without remembering this, if you are going to do chemistry, then it's chemistry. No wonder chemistry is going to be very difficult. You might not believe. Now there are students in, I am doing the O-level, this time O-level batch. Now they have the O-level exam in May. Some students, they don't know the periodic table. They are going to do in 2 months, they are going to do a O-level exam in 3 months. But some of them, they can't write this. You should be able to create this table, not just to write 1 to 20 like leftmost side with the configuration. You should know to which the position or to which group, to which period they belongs in the table. Why? Later you will understand it's but you can easily get the answers for many questions if you remember this table. I'll come to that later. You can tell many properties, many informations you can tell from this table, right, about that element. That's the reason. That's why I'm explaining this much, the importance of this table. So your textbook, they have not given this table this way. I mean, with the configuration they haven't given. With the configuration they have not given, and they have not given only this table alone also, like this way with the group and period. They are going the long form and with the electronegativity, and I'll show the textbook also. So therefore you can understand the importance of this. Now let's come to the last one now. Helium, what is the other one? I'll use a different color for that. Helium, neon, argon, I'll use this color green, dark green, or pale green. I'll use dark green. Okay, dark green, I'll use helium, neon, argon. Where's helium? Helium is He, that is the second element. Helium is He. Then you get neon. Why I'm highlighting the entire thing? They are very special. They are called noble gases. They don't react with anyone, and they are less reactive. They all gases, and they all exist as single atom. They don't combine or plug with anyone else in the table. Their outermost shell is full. Helium, the first energy level, any atom can keep maximum 2 electrons. Helium, that is completed, satisfied. Neon, outermost shell 8 electrons is filled, cannot keep more than that, satisfied. Argon, third one, max, it's occupied with maximum number of electrons filled. Therefore these three are fully satisfied with the maximum number of electrons. If the outermost shell is completely filled, such elements are called noble gases. So therefore this group 8, if you want, you can put an arrow and label what is the special name given to this group 8, guys. Noble gases. They all gases, but there are many other gases in the periodic table. They are called noble gases, and they are also called sometimes monoatomic gases. They don't come, like oxygen is diatomic. In the periodic table oxygen is O, but actually you breathe O2. Okay, so it's diatomic. But helium exists as He. It will never become He2 or neon Ne2. No. Right? So wait, I'll write here neon Ne, neon Ne, helium He, then helium neon, argon Ar. So helium atomic number 2, configuration 2, but one exception, even though it's come to the group 8. Neon, nicely mentioned, 2, 8, outermost 8, group 8. Argon 2, 8, 8, outermost 8, group 8, and all three what is called noble gases. All three are gases. What are the other terms used for these elements? Or noble gases, so monoatomic gases, and they are less reactive, very less reactive. Like there are helium, neon, argon. Like sometimes, what is the lightest gas out of all this? Lightest gas is helium. What is the lightest gas? Helium. Lightest gas, hydrogen. Lightest gas is hydrogen. Lightest element is hydrogen, and it forms the lightest gas. Why? It has only one proton inside the nucleus. Atomic number 1 proton. Less subatomic particles. There are more subatomic particles in the atom become heavier. Helium, the second lightest gas in the world. Second lightest gas is hydrogen. Second lightest gas. Therefore, the most of the balloons are filled with hydrogen and helium. Most of the weather balloons also filled with hydrogen and helium, but helium is safer than hydrogen. Why? Hydrogen is explosive. Hydrogen can catch fire. It's flammable, highly flammable. Hydrogen is used as a rocket fuel, but helium is less reactive. Therefore, helium is safer than hydrogen for filling balloons. Those things also you should know. And now you can see there's a nice pattern, right? Outermost electron equal to the column number, group number. See whether it's except helium, everything else that is valid. Outermost 8, group 8, outermost 7, group 7, outermost 6, group 6, outermost 5, group 5, outermost 4, group 4, outermost 3, group 3, outermost 2, group 2, outermost 1, group 1. There are 2 shells, second period. If there are 3 shells, third period. If there are 4 shells, fourth period. If there's only 1 shell, first period. It's very easy. There's a nice pattern here. I want to learn that pattern rather than just memorizing this table alone, no use. So how periodic table is constructed. Now you can see what is the basis of the periodic table. Basis of what? Electronic configuration. Now again I'll go to the beginning. What is the first thing you should know? Atomic number. Number 2, configuration. Number 3, the position of that element in the periodic table. Then you can get easily the, when you are answering now, by most probably first week of April, most probably, or first week of May, I'll start the paper class. Most probably first week of April or March, I'll let you know, not by next month. Then by that time you can complete the first term work. I'll start, because this time the O-level batch I am finishing in April. So after the air class, so otherwise I don't have time, I'll start your paper class. Then you'll understand when you answer in past papers, provincial paper questions, MCQs and essays, how important this table, right? Therefore, you can, if you can at home leisurely, you can construct this table in a separate board or board, and you can paste that in front of your table, studying table. You can frequently see that, then you will automatically remember these symbols, right? And one more thing, this most of the metals are found leftmost side. Now I am going to draw the boundary between metal and non-metal. Okay, look at the screen. The boundary between metal and non-metal I am going to draw now. This is the boundary between metal and non-metal. Hydrogen, look at here, hydrogen is non-metal, so it's, I'll draw like this. Then lithium and beryllium metal. Then boron is metalloid, look at here, and I'll draw like this, and ladder like this, and like this. Now what is this? This side all these are metals. Metals are found leftmost side. That's why I told a lot of things. If you remember, I think this whole lesson you can remember from this table. One by one I'll teach you. Please draw a line like this. Lithium, beryllium, these are metals. Lithium, beryllium, sodium, magnesium, aluminium, potassium, calcium, these are metals. And this side they are non-metals. This side they are non-metals. You can see here now, metals are found what? Leftmost side. Leftmost side bottom, because leftmost side top. Hydrogen, can you please write here, metals are at the leftmost side. Leftmost side bottom, metals. Please write it everyone. I don't have space here. I'll write here. I'll put a stand right. Left side bottom. Left side bottom. What? Metals. What are the metals here? Lithium metal, sodium metal, potassium metal, beryllium metal, magnesium metal, calcium metal, aluminium metal. Example, cooking pot, aluminium. Left side bottom, left side below, you get metals. Are you all right in this? Don't just wait. Even though class is online, the exam is not online. It's physical, right? Okay. Therefore, you're writing very important all what you're writing here. Or you can take a screenshot also if you want. If you want, you can take a screenshot of this. Left side below you get metals, and right hand side, helium, neon, argon, fluorine, chlorine, oxygen, sulfur, nitrogen, phosphorus, carbon, silicon. Actually they are non-metals. Rightmost side top. Rightmost side you get non-metals. Non-metals can be solid, liquid or gas. Some non-metals gaseous non-metals, and some of them solid non-metals. I'll put a star for this one. Put a look at the screen everyone. I'll put a star for this boron. I'll put a star. This silicon I'll put a star. Why? Silicon and near silicon and boron, put a star with a red pen. These two are called metalloids. What are these? Metalloids are found in the middle. Between metals and non-metals you get metalloids. metalloids. What is the meaning of metalloids? Metalloids means they show both metallic and non-metallic properties. I'll put a star right here. Metalloids, there are two metalloids, that is boron and silicon. B boron, Si silicon. These are the two metalloids. Why are they called metalloids? They are actually they show both metallic and non-metallic properties. These are the two metalloids. So they are found, metalloids are found between metals and non-metals, in the middle of the periodic table. Right. So now today what did you learn? Electronic configuration, and from the electronic configuration how to construct the periodic table. Right? How to construct the periodic table. Now let's see the next week how this electronic configuration useful when predicting ions, their reactivity, whether it's positively charged, whether it's negatively charged, the valency, how do they combine, that also based on this table. Anyone still copying down? Shall I read this? Now it's almost 7. No, it's almost 8 o'clock, right? It's almost 8 o'clock. If you want, you can take a screenshot also if you have missed anything. Done. Please raise the hand also still writing. You should use separate CR book for this. One CR book, chemistry, don't write anything else there. Don't write answer questions. Only theory notes, summary notes, short notes, one CR book until your O level. Chemistry, separate CR book. Additional notes like this, special notes, flow diagram, concept map, mind map, or summary table, flow diagram. So you have to copy down separately other than the theory table. That will be very useful when you're studying for the exam. Right, okay, then it's almost 8 o'clock. We'll stop for today. Good night and God bless you all. And see you all next week. We'll continue. And physics and the questions in the theory tube and the textbook, I'll be discussing in the paper class. Since some students missed that lesson, when I'm discussing the questions, I'll explain the theory of that. Don't worry. Right, okay, then we'll stop for today. Good night and God bless you.